Have you ever wondered how robots can see the world around them, or how AI systems can make sense of images and videos in a way that is similar to how humans use their eyes? It's all thanks to a fascinating field of technology called computer vision. In this video, we're diving deep into the science of how robots and artificial intelligence can interpret visual data, turning it into something they can actually understand. Let's break it down and explore this amazing technology that's slowly but surely changing the way machines interact with the world. To start, imagine you're a robot with a camera for an eye. The camera sees the world just like a human eye, but it doesn't interpret the images in the same way you do. While your brain automatically processes what you see, a robot needs something much more specific to make sense of its surroundings. That's where computer vision comes into play. It's essentially the technology that allows robots and machines to see by analyzing visual data. But how does it actually work? When a robot looks at something, the camera or sensor captures light patterns and converts them into digital images, which are essentially just pixels arranged in a grid. Each pixel holds information about color, brightness, and the intensity of light that hit it. But a robot doesn't inherently know what any of this means. The real magic happens when the computer, which processes this data, begins to use algorithms to analyze and understand the visual information. The first step in the process is image acquisition. This involves capturing an image through a camera or any other visual sensor. The camera can be one of many types, from regular 2D cameras that you might be familiar with, to more complex 3D sensors that can map the depth of an environment. Regardless of the camera type, all it's doing is capturing raw light data, which is then translated into an image that the robot's brain can process. Next comes the step where the raw image data is prepared for analysis, and this is where things start to get interesting. The raw image, which is often just a collection of numbers representing light intensity values, must be processed so that it's usable. To do this, the computer uses various algorithms designed to detect patterns, shapes, and important features. For example, edge detection is a common technique used to identify the boundaries of objects within an image. By analyzing changes in light intensity, the algorithm can outline objects, creating what's called a binary map that highlights the important features of the scene. Once the image is processed, the next step is interpretation. Here's where machine learning comes into play. Machine learning, especially deep learning, has allowed AI systems to train themselves to recognize patterns in images. In the early stages of development, the system may not know what it's looking at, but over time, with enough data, it learns to recognize objects by analyzing thousands or even millions of images. It's similar to how humans learn to recognize things. They see something over and over again, and over time, their brain builds a mental model of what that object looks like. For robots, this learning process is called training a model. The model is a set of mathematical functions that describe how to interpret images based on the patterns it has learned. For example, a robot might learn to recognize a cat by studying thousands of pictures of cats and learning to differentiate the features that make a cat, like the shape of its ears, eyes, and whiskers. The more examples it sees, the better it becomes at recognizing cats, even in different environments, lighting, or angles. But how does the robot actually understand what it's seeing? It doesn't understand in the way humans do, but it processes the data in a way that makes it actionable. For example, a robot can identify an object and use that information to perform a task, whether it's picking up the object, avoiding it, or interacting with it in some way. This process is often powered by a combination of computer vision and other sensors, like light detection and ranging, which helps robots see depth and distance. There's another aspect to computer vision that's vital for robots to interact with the real world: object recognition. Object recognition is a subfield of computer vision where a machine is trained to identify objects from a list of known categories. A robot may be taught to distinguish between everyday objects, like a chair, a cup, or a person. To do this, the robot uses a trained model to scan the image for recognizable features, and then compares those features with previously stored examples of the object it's looking for. If it finds a match, It identifies the object and uses that knowledge for further decision-making. Now, you may be wondering, how do robots deal with things like movement? The answer is motion tracking, another critical component of computer vision. When robots need to track moving objects, they rely on optical fluid technique that analyzes changes in image patterns over time. By comparing two consecutive frames of video, the robot can figure out how objects are moving and in which direction. This is essential for applications like self-driving cars, where the vehicle must constantly be aware of its surroundings, even as other vehicles, pedestrians, and obstacles are moving. One of the most impressive capabilities of robots with computer vision is the ability to perform visual localization. This is the ability of a robot to figure out its position within an environment by recognizing visual landmarks and features. This is crucial for robots working in dynamic environments where GPS or other navigation systems might not be reliable. For example, a robot vacuum uses visual localization to map out the layout of a room, detecting furniture and obstacles along the way. But of course, it's not all just about what the robot sees. The machine's ability to make sense of what it sees is just as important. And this is where the integration of other types of sensors, like accelerometers, gyroscopes, and depth sensors, becomes crucial. Robots often rely on these additional sensors to understand the full picture of their environment, like determining the distance to an object, or how the robot itself is moving through space. In the world of AI, computer vision has a variety of applications. For instance, it's used in autonomous vehicles, where self-driving cars rely heavily on cameras and sensors to understand the road ahead, identify pedestrians, and react to traffic signs. In healthcare, computer vision can be used to assist doctors in diagnosing diseases by analyzing medical images, like X-rays and MRIs, detecting abnormalities that might be missed by the human eye. The world of retail also benefits from computer vision, with robots using it to scan shelves, monitor inventory, and even help customers by providing information or guiding them to specific products. However, as powerful as computer vision is, it's not without its challenges. One major issue is that visual data can be incredibly complex. Even a simple image can have millions of pixels, and the interpretation of that data depends on many factors, such as lighting, angle, and background noise. This is why robots sometimes struggle to accurately identify objects in cluttered or poorly lit environments. Additionally, robots need to be able to generalize what they learn across different scenarios, which can be tricky. A robot trained to recognize a red apple in one set of conditions might fail to recognize the same apple in a different lighting condition or from a different angle. The future of computer vision is exciting, though. Advances in deep learning and neural networks are allowing robots to see the world with greater accuracy and nuance. Researchers are working on developing more robust algorithms that can handle the complexities of the real world, like recognizing objects in cluttered scenes or predicting the movement of people or objects. As AI systems continue to evolve, robots are becoming more capable of interpreting visual data in real time, enabling them to perform more complex tasks, from sorting packages in a warehouse to assisting in search and rescue operations in dangerous environments. In conclusion, the way robots see the world is fundamentally different from human vision, but it's an incredible blend of camera technology, algorithms, machine learning, and sensory data. By processing visual information, robots are able to interact with their environment in ways that were once thought impossible. And as the technology continues to improve, the possibilities for what robots can do with their vision are limitless. We're just scratching the surface of what robots can see and how they can use that vision to change the world around us. So the next time you see a robot, remember that it's not just looking around, it's actively trying to make sense of its surroundings, learning from what it sees, and adapting to perform its tasks with precision. Who knows? One day, robots might even be able to see the world in ways we haven't even thought of yet. If you found this video fascinating, make sure to hit that subscribe button for more awesome tech content. Stay tuned and join us on the journey to uncover the future of robotics and AI.